Happy final day, everyone. It's good to see you all this morning. Some of you may know me from various past projects going back 20 years, back to Asterisk, pre-Free Switch, early Free Switch user. Done a variety of startups in real-time communication space, healthcare, AI, a couple of other random projects, et cetera. So after the sale of Star to Star, I've taken the last 3 years since then, little time off from the crazy startup life and dealing with investors and what have you, and have kind of gotten back to my roots of when I first discovered our Apple II and 286 and such, and got back to kind of a little bit of play and taking on some interesting projects. So what I'm here to talk about today is Willow, an open source voice assistant, which is open source throughout the full path, from the hardware to the inference and compatibility with what we call various command platforms. So, of course, the first question is why? And getting back to this this roots of play and that concept, most of us being makers and tinkerers, et cetera, we don't need a why, right? It's because you can. But where it really starts off is Alexa, or Google Home, Siri, et cetera, has entered our lives in various factors. And at this point, something like 9 years or so after the initial release of the kind of Alexa and Echo ecosystem, which kind of really kicked off the smart speaker in home applications, Amazon has now sold a remarkable 500 million devices, which is, if you take the US population, it's a worldwide platform, right? But if you take the US population, that's like 2 for every adult at least. Just incredibly successful, at least in terms of their sales numbers. In terms of practice and usability, for those of you that have Echo devices, a little bit of a different story. So to start off a little bit here with kind of an obnoxious self-quote, what I like to say at least is, a voice assistant is like inviting someone into your home. You need to be able to trust them, and ideally they're not annoying. So why can't Alexa be trusted? It always starts with an always-on microphone, and a lot of us that are kind of a little more technically sophisticated and understand what's really going on here, many people just refuse to let this thing in their house, and that's perfectly understandable. Amazon has gone, kind of a little bit out of their way to provide kind of like audits, and it's been extensively studied. It has a hardware mute microphone button, and in various teardowns, et cetera, it's been shown that it is an actual physical cut for the microphone, that the state can't be modified with software. But of course, what's the point of this thing if you have to run over to it and mute and unmute? You might as well just take your phone out of your pocket and do whatever you're trying to do anyway. It's sold as a loss leader, and this is kind of one of those things where incentives really matter. And needless to say, the incentives of a user bringing this thing into their house and whatever Amazon is trying to do with it, those incentives don't necessarily align. So you kind of have to ask this question of, what's Amazon really trying to do with this thing? And of course, that answer is, they're trying to sell you more stuff, right? They want more packages coming to your house, whatever else. And then there's well, what are they doing with their data? I think somewhere in the Alexa app on a device, there's terms and conditions, but obviously, who reads those things, right? We don't need to spend any time talking about terms and conditions. And it's an extensively moving target, especially lately. Amazon had published some financials last year, and the Echo division is just bleeding money all over the place. And so they've gotten significantly more aggressive in terms of trying to sort of make Echo kind of worth their while in terms of the development efforts and this whole kind of loss leader concept. And with that, certainly over the last probably even 12 months, many people have noticed that the utility has gone down and that annoyance factor has gone up. And it's completely closed, right? It's their platform. They're going to do whatever they want to do, and you're just, standing around stuck with this thing in your house, and you have no ability to control what it's doing or how it functions. And it's extremely annoying. As I was writing this, Echo devices increasingly have LCD displays. And I looked over at my, my kind of test and demo Alexa environment, and sure enough, there's, a Barbie movie billboard on the thing. And it's like, well, who hasn't heard of the Barbie movie at this point? I don't necessarily need to be reminded of it every time I walk by an Echo device. And as part of this kind of annoyance factor and trying to drive more functionality and get people to engage with the platform and serve Amazon's business goals, there's the, Alexa, turn my lights on. That's what I want you to do. Turn the lights on. And she'll frequently basically try to become your friend and get into a conversation with you. Like, oh, by the way, did you know I can do blah, blah, blah? And that's where the infamous shut up, kind of comes in. And, she finally gets out of the way and goes back to sleep. And then they have this skills ecosystem with these integrations. But the way it's essentially structured is, think of it kind of like an app store if you're not familiar with it. And the grammar is very odd. So when there's an app in the Alexa ecosystem, or what they call a skill, essentially there's like a keyword that's associated with that app as part of the approval process. And the grammar is a very fixed, Alexa, ask BMW to turn the car on, things like that. So it's not exactly natural. And given that this is primarily a voice interface, the discoverability is absolutely terrible. So you go into the Alexa app and you turn on a half a dozen skills. You don't remember what's what. You don't know what grammar they support. Sometimes the names change. It's completely confusing and a terrible user experience. So got to the point where I'm like, I just want to get this creepy and annoying thing out of my house. And where this actually started goes back to 2020. A company that I was consulting with essentially came to me. It was a healthcare, digital health technology company. And COVID, they're trying to reduce touch surfaces and reduce, disease transmission, et cetera. And, I kind of took this on and I thought, okay, I love to stand on the shoulders of giants wherever possible, just like building multiple startups based on FreeSwitch and a variety of other open source platforms. So let's just see what's out there. Let's see how we can possibly pull this off. So between hardware, AI, et cetera, 2020 might as well have been 100 years ago, like Thomas Edison or something. And looking at this, it's like, well, obvious. A good starter here is a Raspberry Pi. That's kind of the, one size kind of fits all, jack of all trades, maybe kind of master of none. And well, obviously you need to get audio into this thing. And a lot of these projects that have been attempted, they sort of enter this with the concept of, oh, you just rig up you find some random microphone and you rig it up to a Raspberry Pi and you talk to it. And what a lot of us know about voice especially, this is why I'm especially excited to present this to this room, is people get really weird about voice. We've kind of evolved and developed in these small groups where you're talking to somebody that's directly in front of you. There's no latency, there's no packet loss. You can have these dynamic real-time conversations. And in the kind of telephony or real-time communications space, we know that things start to get really annoying, maybe call it 500 milliseconds, and you start talking over each other, and it just kind of completely falls apart at that point. So now you've got this case where you have just some random microphone and you're trying to talk to it from 25 feet away. It's not optimized in any way for dealing with acoustic effects of the environment or different speakers, whatever enclosure you might necessarily put it into. As I've studied this more and more and done a lot of experimenting, I discovered there's actually an entire field of research in a cottage industry for acoustically optimized enclosures, where you start getting into things like the microphone cavity, wherein like within the enclosure, okay, what is the configuration of the plastic in the enclosure for not only the sort of external access to the microphones, but the actual like layout and arrangement of all of the other components within that enclosure, including the speaker, et cetera. Then ideally, it'd have some amount of displays or buttons or switches, going back to like, I love buttons. Most of you probably love buttons. I love like, configuring GPIOs and those kinds of things. And ideally, even though you're building it and it is under your control, you'd be able to do things like, the physical hardware mic deactivation. Yeah, ideally, we'd be able to implement that as well. And then meanwhile, you've now got this, pile of wires. It looks like a science project. We see them around all over the place at ClueCon certainly, but it's very, very, very far from, of course, a polished commercial device from somebody like Amazon. And what I discovered is this fundamentally just doesn't work. And then even if it did back in 2020, well, now that we can get even if you could get relatively clean audio and get this thing to kind of function, what do you do with that audio? And there's been, needless to say, a significant amount of development, in this area. And I'm glad Zoa's down here in the front row. If you missed his talk yesterday, he did a far better job than I ever could, kind of giving some of the background and kind of current state of speech recognition, not only in the open source world, but also in some various commercial platforms, which have also been discussed in this room and on this stage. So again, assuming you can get some sort of Raspberry Pi or similar based approach, by the time you get the Raspberry Pi, the power supply, the SD card, the enclosure, you figure out some kind of microphone thing, a speaker, et cetera, you're looking at a per unit price point of 4 times the cost of an Echo device, roughly. When you look like, worst case scenario, an Echo Dot or something like that is like $50, and Amazon's frequently slinging those things and cranking them out for $20 or whatever. And when we go back to the 500 million devices, there's clearly a very common popular use case where people have 4, 5, 6 of these things in their home or wherever. And like anything in quantity, 4x the price point, that doesn't seem that bad. Maybe, from $50 to $200. But then it's actually 5 or 6 in quantity, and so that starts to add up really quickly. With the Raspberry Pi and other open source frankly like cobbled together platforms, the available wake word engines are still absolutely terrible. I like to think of wake words like the power button. It needs to work reliably and predictably. Like the user experience of, you press a power button and it works, 50% of the time, extremely annoying. So wake word is very important. And then you also don't want to do what's called false wake activation, where, a lot of you have probably seen with Alexa, like she just activates for some random reason and maybe starts talking and picks up random audio. Essentially the equivalent of a power button just kind of randomly turning on, which is unacceptable. Completely unacceptable, certainly for anything else and for audio interfaces as well. Back to the, if you don't have a wake word and you need to walk up to something and actually do something, if the accuracy is poor and the wake word activation is bad and the transcription and the speech recognition is bad, now you're repeating yourself, and depending on that latency, whatever else, you're back in the same scenario of just take your phone out of your pocket, reduce the frustration, don't drive yourself crazy, and just do whatever you're trying to do anyway. And not to rag on this Raspberry Pi sort of tinkerer-based approach, we're certainly mostly familiar with what I like to call the family acceptance factor, right? So there's still a big difference between, something in your office or the lab, this jumble of wires and this kind of science project looking thing, and someone being okay with that, in their bedroom or their kitchen or their bathroom or their living room, wherever. So The 2020 project was just a complete failure. The physical hardware wasn't there yet. Speech rec was basically a joke. And we had a variety of developments kind of in the AI space as well as the hardware space. And our friends at Espressif, which many of us are familiar with them going back to the 8266 and ESP32 platforms, developed a couple of different things. So the real key enabling piece here for the Willow, the physical hardware, is the ESP32S3 chip, which is remarkably powerful. And so Espressif took that chip, and they essentially, made a very polished commercial device that you can take out of the box, and okay, now we're getting closer. So what is this thing? So it's $50, quantity one. Go to Pi Hut, Mauser, DigiKey, wherever you get your favorite little technical toys, and it's there, and they'll get it to your house. I like to say it's, order, ship, take it out of the box, flash, put on the kitchen counter, and it's not going to look crude or out of place or, terribly offensive to most people. It's an acoustically optimized enclosure. I talked a little bit about microphone cavities and internal component layout, speakers, et cetera. Espressif has taken on that challenge and basically implemented those approaches within the ESP box. And then there's you can actually get it. So even back in 2020, that was kind of the start, as I'm sure many of us remember, of a lot of these supply chain crunches, et cetera. And here we are 3 years later, and the Raspberry Pi itself is still a little dicey to get. And then you start looking at the bill of materials of these microphones and speakers and switches and et cetera, you pretty quickly end up in a position where not only are you not going to get 5 or 6 of them, you may not even be able to get one between all of those various components. However, capable hardware, of course, needs capable software. This is a great platform. Espressif calls it a development platform. But obviously, something needs to run on it. So that's where Willow comes in. We support the ESP box, the $50 device that I just covered. They also have a variant called the ESP box Lite. That's $15 cheaper, which again, you start buying 5, 6, 20, 100 of these things, whatever, that adds up quickly. Thanks to Espressif, the capabilities of the ESP32S3, they have a speech recognition framework with a wake word engine. So now we've got a reliable power button, essentially, for device activation. So obviously, activation is one thing, but then you need to figure out, okay, the speaker stopped speaking. Now we need to take that audio and do something with it. So they have voice activity detection in this ESP-SR framework as well. And audio processing. So I talked about the difference between, a lot of these Raspberry Pi approaches, to beat up on them again, sorry. You'll see these YouTube demo videos and stuff. And it essentially, in many cases, boils down to somebody yelling at the thing, even though it's 3 feet in front of them. And then you get into the well, how many takes did this take to actually, produce a usable demo? Where, of course, the real-world use case is 25 up to 25 to 30 feet away, or 10 meters for this guy, give or take. And so it has within basically the ESP-SR framework and the ADF framework, there's what they call the AFE, the audio front end, that uses the relatively advanced capabilities of for a microcontroller of the ESP32S3 to do a variety of things like blind source separation, noise separation, acoustic echo cancellation, et cetera, so that you actually get remarkably clean audio, even under challenging acoustic conditions and far-field conditions. And then we support either on-device command recognition, where the audio never leaves the device, or streaming to the Willow inference server, which uses a highly optimized Whisper implementation that we've developed. And so getting into that, it's still relatively hard. And again, Zoa did a significantly better job than I could covering that yesterday. If you missed his talk, I highly recommend that you go and find a video of it or whatever. And assuming he's not too jet lagged, maybe even pull him to the side and cover that a little bit more. He's looking pretty good, relatively speaking. So what happens with speech to text with Whisper? It's still slow and/or inaccurate on CPU, depending which model you use. You still need relatively clean audio, and that kind of gets interesting. And there's a variety of different experiences and perspectives on that. The Whisper model itself isn't technically real time, so you've got to kind of buffer this audio up and then hand it off to the model, get the transcript back as fast as you possibly can to be able to do something with it. It performs somewhat poorly with short speech. You think of a command like turn on the kitchen lights. That doesn't give the model a lot of context to generate something that makes sense. So that's still a little bit of a challenge with Whisper, although it's been demonstrated within Willow in the community that it's still very much usable at a minimum. And again, performance and latency optimized. At the point you're waiting 2 or 3 seconds for a transcription to come back, I mean, that's enough time to actually find your phone, wake it, and do something in an app. So that's also just completely unacceptable. Whisper also famously has issues with occasionally inconsistent output. So things like turn on, turn off, they might be hyphenated, they might not. Sometimes they're capitalized, whatever. So in some cases, you need to do a little bit of post-processing, even with the Whisper transcription, to get it to line up with whatever your command platform might be. And then you have, okay, this thing actually captured my speech. It did what it's supposed to do. And obviously, if it's turn on the kitchen light and you're in the kitchen, you can observe naturally if the light turns on or turns off. But in many cases, you don't get that kind of physical environment feedback. So you need to know what actually happened with this thing. And this is another one of those things that has been covered very well on this stage and elsewhere. The open text-to-speech models are a little rough. There are voice quality issues. There are speed issues. And generally speaking, compared to a Azure Cognitive Services voice or some of these other kind of highly optimized neural approaches, they sound or can sound relatively robotic relative to those highly polished commercial solutions. So we do things like caching to improve the speed and the response. So turned on light is basically served from RAM at that point, comes back extremely quickly. And then when speech actually needs to be generated, we currently use the Speech T5 implementation from Microsoft. So I like to say Willow doesn't actually do anything. It gets this transcript back, and then it provides it to what we're calling the command platform. Home Assistant, another thing I've been a huge fan of for a decade since the initial release. It's kind of our primary targeted platform because they've done a lot of work within Home Assistant as part of 2023. They've deemed it the year of the voice. So we stand on the shoulders of that giant as well for a lot of the kind of typical home use cases. We also intend to be command endpoint platform agnostic. So we support OpenHAB. And there's a generic REST HTTP endpoint as well, where we take that transcript that comes back and we send it wherever you want with an HTTP post, and you can do whatever it is that you want to do with it. And then, of course, Willow is, I think, roughly from concept to now, maybe 6 months old. And we're still, of course, very much doing active development internally within the team and also in collaboration with the open source community. So it doesn't really do anything, but it also kind of does, right? So how does this work? And if I were a little more graphical or visual, I could have some nice little diagram for you. But it's simple enough that it's wake, stream the command, detect the command, stop at the end of the speech, take the transcription response, send it to the command platform, and then display or speak the command status. And then my favorite, just get out of the way. I have enough friends as it is. I don't need to have some sort of personal relationship with Alexa or whatever. I want to accomplish something. I want it done as quickly and efficiently as possible. So basically, Willow shuts up itself. You don't have to yell at it. And 18 seconds left. I don't know if we have necessarily any time for questions, but I'll certainly be here the rest of the day.
Kristian, we do have time for questions, my friend.
Nice.
Bang.
Okay. Any questions? Anyone?
And we even have a man at the back with a microphone who can run it to you. That was an amazingly practical talk, Kristian. Thank you. Who's got a question for Kristian?
Looking like I'm getting off pretty easy. All right.
It kind of is.
Yeah.
Oh, Zoa. There you go. Look, just right there. Hold on. The microphone is coming your way, Zoa. It's a speech-activated microphone.
How far do you get with the optimization of, let's say, the onboarding, flashing progress? I know you're working on it. I don't know how far you got. I don't know if you saw Dan's speech yesterday about doing it all from the browser.
Yes. So this is one of these things where the initial very soft announcement was like literally a show HN post, and you never know. Like I love all my stuff. It's like a proud parent. Like everything that I do is the greatest thing ever. But you never know what the reception of the community or the rest of the world is going to be. So a month in, still extremely rough. Did a show HN post, and next thing I knew, it was like top of the front page for 3 days, and ESP boxes had sold out worldwide. And what's interesting about that is we actually went out of our way to make the onboarding process basically as difficult as possible. If I was really looking to scare people off. I know that this was early and this is a kind of a challenging application. I didn't want a huge influx of potentially like relatively technically unsophisticated users. But with that, now that we've, thanks to a lot of testing and collaboration with the open source community, we've fixed a tremendous number of bugs, just across the device and the platform. And we're now, confident that we're at a place where we can have a more sort of end user accessible Flash process. And that essentially comes down to you install what we call the Willow application server, which is a dynamic configuration platform that's completely web-based, does over-the-air updates, pulls stuff from GitHub. You can manage multiple devices. You can reset them. You can change basically any aspect of the configuration. And most importantly, you click a link within the locally hosted Willow application server, and it takes you to a web serial-based flasher. You plug, again, take it out of the box, plug it into your machine. Chrome will ask, prompt for permission to the serial port, and it flashes and runs. And that's something that we've it's been our primary focus for probably the last month or so. And that should, depending on how I'm feeling today, let's just face it. But that's something that hopefully we'll have out next week, actually.
Good stuff. Thank you, Kristian. Are you going to be participating in dangerous demos this afternoon, Kristian?
Of course. Yeah.
Excellent. Well, something to look forward to. And thank you for your questions, Zoa. Do you feel it was answered?
Yes.
Zoa feels it was answered, so that's excellent. Okay, I did see Alberto getting mic'd up somewhere. There he is. Okay, so Alberto, if you'd like to come and get mic'd up. But in the meantime, let's say a very big ClueCon thank you to Kristian Kielhofner.